All right, let's pull back the curtain on our digital world. We're going to reveal the secret architecture that powers, well, pretty much everything, from your social media feed to your favorite game. Let's dive right in.
So we're going to start with a simple question. It's kind of a mystery that you experience every single day, probably without even realizing it.
I mean, seriously, have you ever stopped to wonder how Google can search the entire internet in like a split second? Or how a game instantly pulls up your high score from a list of thousands, maybe millions of other players?
Well, spoiler alert, it isn't magic. But it is the secret ingredient, the powerful idea that makes our super fast, super responsive digital world even possible.
And it all comes down to two simple words: data structures. Okay, so what in the world are they?
I know, it sounds pretty technical, right? But trust me, we're going to break this down into something anyone can get. We're about to turn what seems like digital chaos into something that's perfectly organized and clear.
So at its core, that's really all it is. See, a data structure isn't the data itself. It's the container you put the data in. It's the system, the method of organization. And honestly, this is the perfect way to think about it. Imagine a computer's memory without any structure. It's just a messy room. Finding one specific thing? It would be a total nightmare, slow and frustrating. But with the right structure, the shelves, the drawers, everything has a place. It's exactly where it needs to be, ready to be grabbed in an instant.
And this is why it matters so much. You see, choosing the right way to organize your data is literally the difference between an app that feels lightning fast and one that just chugs along and crashes when you need it most. That's why every single serious piece of software out there relies on them.
Okay, let's open up the programmer's toolbox and meet some of the key players. I want you to think of a programmer kind of like a carpenter. They don't just have one tool, right? They have a whole collection of them. And each data structure is like a specific tool, perfectly designed for a specific job.
First up, we've got the most fundamental tool of them all, the array. My favorite way to think of this one? It's the egg carton of data. Super simple, a little rigid, but man, is it effective.
So just like an egg carton, an array has a set number of slots, right? You put your data in, and because all those slots are stored right next to each other in one continuous block of memory, the computer can jump to any item instantly. It's perfect for something like, say, a list of student grades, where you know exactly how many students are in the class.
But, okay, what if you don't know how many items you're going to have? For that, we need a different tool. And that's where the linked list comes in. This one is less like an egg carton and more like a scavenger hunt.
Now, this is where we see a really important trade-off. Unlike that rigid array, in a linked list, each piece of data just points to the next one in the chain. So what's the benefit? Well, it's super easy to add or remove a song from the middle of your music playlist without messing up the whole thing. But there's a downside. If you want to jump to song number 50, you can't just go there directly. You have to follow the first 49 links to find it. So yeah, it's way slower for accessing a specific item compared to an array.
All right, next up in our family of linear structures is the stack. And the rule for a stack is super simple and very strict. Last in, first out, or as you'll hear it called, LIFO.
The absolute best way to picture this is a stack of plates. You put one plate down, then you put another plate on top of that one. Now, when you need a plate, you're not going to try to pull one from the bottom of the stack, are you? No way. You take the last one you put on, the one right on top, and get this. Your browser's back button, it works exactly like this. It's just a stack of all the web pages you visited.
Okay, so if that's a stack, what's its opposite? That would be a queue. And its rule is just as simple, but flipped. First in, first out. FIFO. And you already know exactly how this works. It's just like a line at a ticket counter. The first person who gets in line is the first person who gets served, right? This structure is absolutely perfect for managing tasks, like when you send a bunch of documents to a printer. The very first one you send is the first one that comes out. Okay, so everything we've looked at so far, arrays, linked lists, stacks, queues, they all work in a straight line, one after another. But what about more complex relationships? For that, we need to move to non-linear structures, and we'll start with the tree. And yeah, you can think of it just like a family tree.
A tree is all about hierarchy. You have a single starting point, the root, and that branches out into children, and those children can have their own children, and on it goes. This is precisely how the folder system on your computer works. You've got your main drive, and inside that you have folders, and inside those folders you have even more folders.
And that brings us to our final and maybe most flexible structure of all, the graph. Now, if a tree is a neat top-down hierarchy, a graph is, well, It's more like a web of connections. It's your social network. So what is a graph? It's really just a collection of points, which we call nodes, that are connected by lines, which we call edges. Think about it. You are a node, your friends are nodes, and the friendship between you, that's an edge. Or think about a map. Cities are the nodes, and the roads connecting them are the edges. This incredibly powerful idea is the engine behind things like Google Maps and pretty much all social media.
All right, so we've toured the toolbox, we've met the key players, now for the payoff. Let's connect all these dots and see exactly how these structures are the invisible engines running the technology you use every single day.
Okay, this is where it all clicks. That social media feed you scroll through, that's a graph connecting you, your friends, and all that content. Google Maps finding you the fastest way home, that's a graph too, connecting locations. What about search engines? They use trees to organize all those billions of web pages, but they also use a clever trick called hashing, which is kind of like a super fast index in a book that lets them jump instantly to the right info. And the whole time, in the background, your computer's operating system is using queues and stacks to juggle all its different tasks. See? These aren't just abstract ideas. They are literally everywhere.
And here is the most important thing to take away from all this. Understanding these ideas isn't just for coders and programmers. It gives you this fundamental insight, a peek under the hood at how our entire digital world is actually built. And honestly, that's kind of like a superpower.
And this quote just says it all perfectly. To master computer science, you have to first master how data is structured. The structure, that is the whole game. It's the invisible blueprint that allows for speed, for massive scale, for all the complexity we take for granted. So the next time you open an app, try to look past the screen for just a second and see the elegant, hidden architecture that's working tirelessly behind it all. Thanks so much for joining me.